I'd like to continue with the little series on rocks, and today we're going to start with looking at some basaltic lavas. That's a fundamental rock type, and that's why I think it's good to devote a few minutes to it. For most advanced geologists, you're perfectly aware of what I'm going to say here now, but for people who are warming up, this might be a good lesson. And I'd like to distinguish the two main types of basaltic lava that there are. And that's the Pahoehoe lava on the one side, which is what I have here on the right hand, and the AA type lava, which is here on the left side. The Pahoehoe lava is often also referred to as ropey lava, while this one is more of a blocky lava, so there's other terms for this. Pahoehoe comes from Polynesian, and I read several sources that don't quite agree. Some people say Pahoehoe is the lava on which you can walk with bare feet. Other people say Pahoehoe is the description of an even surface out on the sea. I think the latter is probably more correct. As opposed to AA lava, which is the one you cannot walk on with bare feet, or the rough surface of the sea. So again, I heard these two interpretations. Maybe I need to talk to some Polynesian person in the near future. In any case, as you see, there's ropey textures here, and this is very important. And here as well, there's these wrinkles on top of the flow. And in contrast, we have blocky lava here, and indeed, it's very, very blocky, very uneven, very sharp edges, while this is a lot more smooth. The issue is that they actually get transported in a different way, and this is what I like to point out. So if we have a Pahoehoe lava flow, and this is the bit that I'd like to show, this would be a flow tongue, for example, then more lava will flow in, and it will start to inflate from an internal overpressure. So we will actually make new lines, new surfaces. It will inflate, and at some point the pressure is so high that it will break out and make a new tongue. And again, this tongue will inflate once there is sufficient magma supply. The wrinkles on the surface, they come from the fact that the top surface has cooled while the interior is still liquid, and therefore they will move at different speeds, and the upper cooled surface will be more viscous, and you will push it together. A bit like the skin on your hot chocolate, if you want. If you blow against the skin, it will start to make wrinkles, and that's exactly what you see here. So this is an example from Iceland, by the way. This is from El Hierro in the Canary Islands. And you get lovely Pahoehoe lava in both of these settings. The contrast in the AA lava is that it moves very differently. Pahoehoe lava, when it cools, can become AA lava, while the other way around is very, very difficult. It's almost impossible. So here is AA lava from Mount Etna. This is from the 2014 Bunga eruption, and here's a piece from the 1736 eruption on Lanzarote. And these surfaces are very sharp, and usually what happens is we are moving the flow more like a caterpillar, or the wheels on a caterpillar, and we are cooling on top. We're making this clinkery, rough surface, and there is a move over, a rollover, if you will, and these clinkery bits of the surface might in part end up below it, forming a bottom as well as a top breccia. So this is usually a different type of flow. It's a little cooler, and it moves in a different way. It moves generally a little slower, and you can usually kind of observe it moving. While these things are more dangerous, there might be new tongues breaking out at any time, so standing in front of the flow is not a good idea, while here you can predict a little better how fast it will move. There is something interesting I'd like to close our little explanation with, and that is while this specimen here looks like a perfect piece of basalt, there's actually a little secret hidden inside, and I knocked it open with a hammer, and it turns out that we have a mantle nodule in there. So here we have a peridotite nodule, and the 1736 eruptives on Lanzarote have quite a good number of them. Some people have worked on these, and I actually have some more from this particular eruption. Here, I'll show you these. And in the near future, I'll talk a little bit about olivine, and these peridotites are made of mainly olivine, but also some clino and orthopyroxene, and often some spinel or garnet. So, thank you for your attention, and this was my little introduction to basaltic lavas, at least the main types, and well, I hope you enjoyed that. Thanks for watching.